Today we are going to be continuing on with graphing our quadratic equations. We're going to do exactly what we did yesterday, but we're going to add an extra step to it and actually physically graph it and not just do a sketch like we did yesterday. So, steps to graph a quadratic equation. We already figured out that step 1, we want to find the axis of symmetry. And for finding the axis of symmetry, we have our formula, x equals negative b divided by 2a, where b is going to be that number that comes before x, and a is going to be that number that comes before x squared. Step 2, we're going to find the vertex, and in order to find the vertex, we take the x we found for our axis of symmetry and we're going to plug it in to whatever our equation is for x. So plug x in to our equation. Okay. Once we have our axis of symmetry and our vertex, we're then going to fill in a table of values, and you're just going to fill in your x's and then plug all of those x coordinates into your equation using a calculator. Once you get your y coordinates for each of them, you're going to plot all of those points, and you're going to have that nice parabola, that U shape that's either opening upwards if our a is a positive value, or opening downwards if it is a negative value. Once we've completed all of that, we're then going to go on to state our domain and our range of each of these. So starting with number 1, we've got y equals x squared. First, I need to figure out what my axis of symmetry is. So technically this equation is actually y equals x squared plus 0x plus 0. So my a term is still going to be what comes before the x squared. So a is going to be equal to 1. B is going to be what's before the x, so b is going to be 0 in this case. And then c is what's tacked on at the end, so c is also going to be 0 in this case. So solving for our axis of symmetry, we're going to plug into our equation. X equals negative b, but my b is 0, so this is going to be a 0, divided by 2 times a, and a is 1. 0 divided by anything is going to give me 0. So my axis of symmetry is going to be at x equals 0. Then I'm going to take this, x equals 0, and I'm going to plug it into my equation to figure out what my y value is so that I have my vertex. So I have y equals x squared, which is going to be y equals 0 squared. And 0 squared is always going to be 0, so y is going to equal 0. And when I write my vertex, I'm going to write it as an ordered pair. X, which was 0, comma, y, which was also 0. Oops. So the vertex of this parabola, or of this quadratic equation, is going to be at 0, 0. Okay? Now I'm going to go in and I'm going to fill out my table of values. And the first thing you want to put into this table of values is going to be your vertex, and that's going to be our middle coordinate always. So we're going to put that in here, 0, comma 0, and then I'm going to go subtract 1 here, subtract 2, and then add 1, add 2. So I'm going in either direction with my x values. So I have negative 1, negative 2, positive 1, positive 2. Now I'm just going to take each of these values, plug them into my equation. Y equals x squared. So I'm going to plug negative 2 in for x. Negative 2 squared is 4, so my y value would be 4. Negative 1 squared is going to be positive 1, so my y value here is going to be 1. And I already have that vertex, so I'm going to go on to 1, plugging 1 in. 1 squared is going to give me 1 for my y, and then 2 squared is going to give me 4. Now that I have all of these points, I'm going to go ahead and graph that equation over here, starting at my origin. Alright, so now that I plotted all those points and connected them, I have that nice parabola shape that is opening upward. And I knew this was going to open upward because my a value was positive. Now I want to go on to state my domain and my range. So domain is going to be the x values. that note up here. And my range is going to be all the outputs for my y values. So for my domain, it's going to be all my x values. And for this quadratic equation, in any quadratic equation, you can plug in any value for x. So my domain, similar to when we did exponential functions, is going to be all real numbers. And then my range is going to be my y values. So you can either look at your table here or look at your graph here, and you want to figure out where your min or your max is. So for this one here, my minimum is the bottom point that my graph reaches. So where it changes that direction, this graph is never going to go below that vertex or that minimum point. So my graph is never going to have a y value that is below 0. My y is always going to be equal to 0 or greater than 0. So my range is going to be y is greater than or equal to 0. Because if I plug in negative numbers, I get a positive for y. I plug in positive numbers, I get a positive for y because they're all squared. So it's always going to come out as greater than or equal to 0. Going to look at one more example together. So we have y equals x squared plus 2x plus 5. So my a value is going to be what comes before x squared. So I have a positive 1 there. That means this is going to open upward. B is going to be that number that comes before x, so it's a positive 2. And c is going to be that last number at the end, positive 5. Now I want to go ahead and find out what my axis of symmetry is. So I'm going to use my formula. X equals negative b divided by 2a. So I have x equals negative, my b value is 2, divided by 2 times a, and my a value is 1. So working this problem out, I'm going to have negative 2 divided by 2, which gives me x equals negative 1. So x equals negative 1 is going to be my axis of symmetry. Now that I have my axis of symmetry, I'm going to take that x equals negative 1 and I'm going to plug it into my equation to figure out what that y value is for my vertex. So I have y equals negative 1 squared plus 2 times negative 1 plus 5. Solving this out, negative 1 squared is going to be a positive 1 because a negative times a negative always equals a positive. So I have y equals positive 1, positive 2 times negative 1 makes this minus 2, then I have plus 5. So y is going to be equal to 1 minus 2, which is negative 1, plus 5 gives me positive 4. And then we're writing our vertex as an ordered pair. So parentheses, my x value, which was negative 1, and my y value, which was positive 4. Now I'm going to go on and complete my table, and we're going to use that vertex as that middle point. So I'm going to enter that in first. So I have negative 1, 4, and then I'm going to subtract 1 in this direction, so I'll have 0, subtract again 1, and then add to go in the opposite direction, so negative 1. Now I'm going to go on and fill in my table. So I have my vertex, that's going to be my first coordinate that I put in here, so I'm going to put that in the middle, negative 1, 4, and then I'm going to subtract, so negative 2, negative 3, and then add to go the opposite direction, so 0 and 1. Then I'm just going to be plugging all of these values into my equation with my calculator and figuring out what I get for my y values. So I went through and I figured out all of my y values by plugging in my x values on my calculator, and then I went ahead and I graphed all of those points in this graph to the right and created that nice parabola shape that is opening upward. I'm going to go then ahead and state my domain. My domain is going to be my inputs, or my x values, what I can put into this equation. That is going to be all real numbers. And then for my range, I need to figure out what, in this case, my minimum is. So where that turning point is. And that turning point is at my vertex. So when y is at 4, y is always going to be greater since it's opening upwards, so it's going above that 4, but it can also be equal to that 4. So my range is going to be y is greater than or equal to positive 4.